Yeah, thank you, Professor. And so this is the next topic of my abstract, that is the evaluating an energy supply system applied to Mars. So in this, as you know, to have a habitat in Mars, we require energy as a vital, important part. And over the past years, Apollo spacecrafts and the space shuttles were powered by fuel cells that were run by reverse electrolysis of hydrogen and oxygen in order to produce electricity. However, this process demands a supply of hydrogen and oxygen, which are very less in Mars. There is oxygen is about 0.74%, 174%, and water about 0.03%. And these spacecrafts were sent in space, but we haven't seen anything done on Mars. So on Mars, maybe it is not possible to carry out electrolysis. So dependence on electrolysis is not possible, and therefore we have changed our field of view to other source of energy. And there were many modifications also made. Next to that, we see many modifications that were made to solar panels, because we have the sun, and we can use the solar panel as the source for energy. And in these solar panels, they have used this direct conversion. So in direct conversion, there is no motor, or there is no other parts attached to the solar panel. They can directly convert the energy from the panel itself. So this is advancement, and this advanced power max advance is that film technology. And this film technology is very helpful, because with this technology, we have a typical solar cells, like having a flat solar cell. But with this thin film technology, we can now bend and flex the cells. So for example, if you want to keep the house shaded with solar cell, we can also do like that. So the shape of the cell can also be changed with the thin film technology. And the ST10 module is this is also a new version of the solar panel. Is a composed of monolithic structure of series connected copper, indium, and diselenite based solar cell. So this have also it's like one stage above the thin film technology. In this thin film technology, we are using three thin film technology. So like three thin film. So they are having a multiple layer cells. So in we using a multiple layer cell, we can multiply the power that is multiply the power intake from the sun. So it's like having a lesser surface, but having more power. So we don't need to have a big solar cell bed to take the power from sun. But with this multiple layer, we can make we can like fold that layers into three part, and like that we can use more energy from the sun. So these call as this three multiple layer cell, it's called as a power max thin film technology. And this used by Siemens. They have proposed this technology, and that are characterized by a exceptional spectral response and long term performance integrity. So yeah, and they also give the same benefits as a photovoltaic module, and of a crystalline photovoltaic modules. So we have the same power, like the same process, but here we can use the three multiple layer, or more than three layers technology. In the modification of the solar panel, we look into the second modification, that is a parabolic system. If we look at this, it is like better understandable. In normal solar cells, we can only use in the morning, or in the time when there is sun, from morning to afternoon. But the challenge starts when we having to produce this power after afternoon, or from when there is no sun. But with this parabolic technology, we can use the focal line, or we can modify the focal line, and then we can use it also in the evening also. So that is extra benefit that we get from the parabolic system. So if I read out this thing, this receiver contain a heat transfer fluid, that is synthetically thermal oil or molten salt, which is heated by the focused sunlight, and it is circulated in these tubes and pumped through heat exchanger to produce steam. So this solar cell not only act as a like for example, it also act as a hydro hydro power station. So the sunlight that is falling in the morning to if afternoon, that heat is now, the extra heat is transferred to into heat exchanger, and the heat exchanger yeah, like they work in the night. So for example, when there is not enough sunlight, this heat exchanger take place and they produce more kind of energy. So that's why we can use this also in the evening. And yeah, like a hybrid power plant. So you can see here the hybrid power plant of the photovoltaic solution is that if we take the power from 8 to 8, like from morning 8 to the evening 8, and then we can power on the this this heat exchanger. And when we power on the heat exchanger, they can carry on the power for a long time. We can also use the batteries in this case. For example, in the night we can also use the batteries. So here you can see that there is a power drop, right? So there is a constant power. But with this thing, when there is morning and they are taking, so there are two process going on together. One is the power cell, that is a solar thermal cell, and the this thing, the heat exchanger. So the heat exchanger is not working in the initial process, but once the night starts, then it start taking place. So we have a constant form of energy. And in the second part that I would like to say is that in the solar cell, we can also have the radiations, like that now the new discoveries are done, so we can use the radiations as as we can absorb the radiation also, and also turn them as a energy. In the next we also see the wind energy in we can also put the wind energy in the Mars, same as the solar cell. But wind energy are not that much effective in Mars. But with a long study, we can put up a different kind of uh, wind power, that is the axial wind turbines and carbon composite materials. So axial wind turbines is small wind turbines, it's not huge. So more small amount of wind can also blow these axial wind turbines. And also the vertical axial wind turbines, these turbines can be used because they can if there is a multi directional wind, if the wind flow in multiple direction, we can also use that kind of wind flow in the vertical axial wind turbine. So any the wind coming from any direction can be used. And one thing that is to be kept in mind, that while building these turbines, we must use the carbon composite materials. And today my methodology or the prototype is to combine the wind power and the solar energy into a one machine, so that we can use simultaneously two power into a one. So that is the duo power source. In this dual power source, what I have done is this is kind of a rotary device. And as you can see, there are a lot of solar panel connected to it. So for example, if we talk about the daytime, in the daytime the solar panel can adjust, they can also adjust, or they can turn their fins towards the sun. So they can take the sun energy from the solar energy in the daytime and can use them. So in this fins we can use the modified solar panels to have the utmost energy that input. And during the so we can take the energy from this, and we can also store them in the batteries, or we can yeah, by the by the parabolic solar cells, we can also use the energy at night also. But at night there are a lot of sandstorms. So in due to that, the solar panels are covered. And so here we I have done is that this is a moving body. So at night we have a lot of windstorms. So this windstorm can rotate this panel, and like that, likewise we can clear off the sand from the solar panels. So at the night we can use wind energy, and in the morning we can use this solar energy. But the advantage of using both in one power source is that the solar panel would not be covered by the sands in Mars. So at night we can rotate the device so that the dust falls off from the solar panels. So these are the briefing of what I said. And so the conclusion is that it is considered that use of advanced solar panel on the roof of Mars And we can also use the thin layer, uh, as I told you about the thin layer panels, that we can use them in also over the roof, because in Mars, outside the atmosphere, it is affected by radiations. So the radiation can also be converted to heat energy, and from there we can transfer it to electrical energy, and that can help, that can safeguard the habitat by making the by making the or by shielding the rooms by this kind of solar panels. And that can also be advantage over the normal rooms. So the more the advantage, a solar cell has a potential to convert energy from the radiations too. So yeah, so the radiations can also be converted. So that's a good point, because we can then cover the rooms, or the shield the rooms with these solar panels, and they can also convert the radiation into power source. So that is this discussion about my duo power source, and how it can be effective in Mars. And these are the references I have taken. And thank you very much for listening. I would like to have some questions.